Okay, today in IM1 we're going to talk about the shapes of distribution. So these are some shapes, but we're going to go on and get started. The overall shape of a graph is called the data distribution. The data distribution is the way in which the data is spread out or clustered together. The shape of the distribution can reveal a lot of information about the data. There are many different distributions, but the most common are symmetric, skewed right, and skewed left. So if you look at this, when it tips to the right, it's called skewed left. So this is skewed left. You could say it's leaning right, it's skewed left. Okay? Symmetrical means that the data on the right of the distribution are approximately a mirror image of the data on the left. So you look at this, it doesn't have to be exact, like this one could be this low and this one could be this high, but it's pretty symmetrical. Okay? This one is definitely leaning left, and the tail is to the right, so this one is skewed right. So look at these descriptions in a little more detail. Read them carefully. These are with histograms, but you could also have data points or other ways to look at the graph. So if all the bars of a histogram are about the same height, then the distribution is called flat or uniform distribution, and that would be called symmetrical. What they're talking about is something that looked like this. You know, all of them were pretty close to each other. Okay, maybe one would be a little bit higher, but they're pretty close. Okay? Alrighty. Okay, so this is what we call a normal distribution. And when you do a lot of statistics, you'll find out a lot more about a normal distribution. And what they've done by studying a lot of different things is they found that a normal distribution will have one standard deviation within 68% of the data will be within one standard deviation. Okay, so we've already learned about standard deviation, and so you would say, let's say the mean is 50 and our standard deviation is 2. So we would say, we would add 2 and subtract 2, and we would say 68% of our data would be between 48 and 52. This is for a symmetrical distribution. Okay, then we go out 2 more, that would be 46 and 54. We would say 95% of our data would be between 46 and 54. Now remember, we only use the mean when it's symmetrical, so that is why this applies here. Okay, and then if we go out one more, 3 standard deviations would be 2 times 3, because we said our standard deviation is 2, so that would be minus 6 would be 44, and plus 6 would be 56, and we would estimate that 99.7% of our data are between 44 and 56, which is our 3 standard deviations of our norm, our mean. Okay, so that's really important for you to understand what they're talking about when they say a normal distribution. Okay, so in Exploration 2 in your journal on page 201, these graphs show the distributions of the heights of 250 adult American males and 250 adult American females. So notice they gave us the mean is 70 inches and the standard deviation is 3 inches. For females, the mean is 64 inches and the standard deviation is 2.5 inches. So which data set has a smaller standard deviation? It is the female. Okay. What does that mean in the context of the problem? It means that female heights vary less than male heights. Okay, there's less of a spread. Then it says, estimate the percent of male heights between 67 and 73. So remember that our mean is 70, and our standard deviation is 3. So 67 is 70 minus 3. That's 1 standard deviation. 73 is 70 plus 3. Again, that is 1 standard deviation. So since it's 1 standard deviation from the mean, we would expect about 68% of our heights, or male heights, to be between those two ones. So that's 5'7" and 6'1". Okay, so that's an interesting little fact. All right, so we're going to look at these graphs and we're going to decide how they are distributed. So this one goes down. I like to draw the line. I think it helps. So it's skewed slightly right. Okay? Remember, where the shortest distance is, that's where you would say. So where the tail is, that's what you say. So skewed right. It's leaning left, skewed right. This one is also skewed right. Notice that I gave you these are the mean, just so you know. This one, I would say this one's pretty symmetrical. But you could also, I think it's pretty symmetrical. Okay, this one is definitely skewed right. This one, since this part, the red line, if you looked at the red line, I would say it's one of those flat ones, so that would be symmetrical. It also looks like this, which is pretty symmetrical. So that's kind of an odd one. We don't know what they're comparing, but we're just looking. Okay, looking here, I would say skewed left, because it's very little over here. It's kind of hard to tell, but it's in the middle. So some people might argue that this is symmetrical, but I'd say it's skewed left. Okay, this one is, again, skewed right. This one here is pretty symmetrical, as is this one. And this one, I say, is skewed right. So we didn't see very many skewed left, but we'll see them as we go along. All right. So describing the shape of a distribution. So they want you to create a frequency table showing the number of raffle tickets. So we're going to go ahead and just show you that. There it is. And if you look at that, it says, what is how do you think it's distributed? So if you look at this, there's the top. I'm trying to draw it accurately here. And it's pretty symmetrical. So here's what they said. The data on the right of the distribution are approximately a mirror image of the data on the left, so it's symmetrical. So I want you to see that they don't have to be exact to be symmetrical. Okay? Alrighty. Okay, the frequency table shows the number of hours that students in your grade spent on homework last week. Display the data in a histogram and describe the shape. So we're going to put that in the histogram, and we look at that, and it is definitely skewed right. Now, why do we need to know if the distribution is skewed right or left or symmetrical? Here we go. So when you're choosing your appropriate measures of center and spread, you need to know what the shape of the distribution is. Okay, when a data distribution is symmetrical, we use the mean to describe the center, and we use standard deviation to describe the variation. When the data distribution is skewed, either way, we use the median to describe the center and use the 5-number summary to describe the variation. Here's why. When a distribution is symmetrical, the mean and the median are very close to each other. Okay? When a distribution is skewed, the mean will go in the direction where the distribution is skewed, while the median will be less effective. So the median pretty much stays in the middle, while the mean moves over. You can see it both in these cases. So we go with the median because it describes the center better. Okay? Okay, this is number 1 on page 203 of your journal. I want you to give this a try on your own and then come back and check. But before you go, let me give you some hints. So the first thing that I would do is look at what they're asking me to do. So it's 26 cities and the average annual snowfall. Display the data in a histogram using 6 intervals beginning with 15 through 28. So the first thing I'm going to do is I'm going to go interval 1 is 15 through 28. And that is a range of 13. So I'm going to remember that. That would mean that my second interval would be 29 through 42. Okay, so you're going to come up with your 6 intervals, and that is your x-axis. Your y-axis is going to be the number of cities, the frequency. So it's going to be the number of cities that had that snowfall. So it's going to look like this. Remember, it's going to be your bins, 15 to 28. Then it's going to be 29 through 42, etc. And then over here, it's going to be the number of cities, okay, or the frequency. Now, when you do this, you've got to figure that out first. So what I do is I make all my bins, and then I just go through it. 22 is in this one, 15 is in this one, 20 is in this one, 15 is in this one, 44 is in number 3, and etc. until I get all my numbers figured out for each of the sections, okay? Then you're going to make your histogram. So go ahead and give that a try and come back when you are done. So push pause at this point and come back when you have got your histogram made. Okay, so here's what your histogram should have looked like. The first question that they asked was, which measure of center and variation best represents the data? So I can see that my data is skewed right. So my measure of center would be the median. Okay, and the measure of spread or variation would be the 5-number summary. And why? Because the data is skewed right. Okay, then it says a weather station lists the top 20 snowiest major cities. The city in 20th place had 51 inches of snow. How would you interpret the data? So I'm going to look up here and I'm going to say, well, that 20th city would be in this bin. So now I'm going to go look at that bin and find the numbers that are in that bin. I find 44, that's below 50. 43 is in that bin. 54 is in that bin and it's greater. 41 is in that bin. And 47 is in that bin. And 54 is in that bin. So of the cities in that bin, only 2 of them are going to be on this list because, and then there's one here and one here. So how I would interpret that is not many of the cities, or very few of the cities that I looked at, would be in that list of 20 snowiest major cities. Okay? And that's what they put. Most cities were not on the snowiest list. So hopefully you understand this. Go back and look at it again if you need to understand a little bit more carefully, and have a great day.